Hey, so we have already made it to our number sense standard 2.3 and 2.5, solving problems with rational numbers, including exponents. Now, I have handwritten out the sample page of practice problems. This year it happens to be a gold page, and we're going to put it's going to be our page 21. Now, I'm going to zoom out here so that you can see that the page will need to be trimmed down quite a bit. So before you even cut it, I really want you to look at your page and understand kind of where it will fit. Maybe you can kind of fold it to find where your crease should be so that it will fit neatly on the page without sticking out. And that way, when you go to work your problems, you'll see that crease and you won't write past it. It's really important that you don't cut it out and glue it until after you've written all the problems. This paper is very, very thin. It's easily smudged, and so you're going to want to be really careful handling the paper. Now, of course, you should be working the problems using a pencil. And hopefully, if you are erasing, you can erase not with a red type eraser, but with the white type eraser. It does do better on this colored paper. I'm going to work these problems in ink only because for the sake of film, it will show up better. Now, page 21 is going to follow our adding and subtracting rational numbers page. And you can see on your paper here, operations with rational numbers. This is kind of our 21 page. And we also need to go to our table of contents, always, and add for page 21 that we are doing in 2.3 and 2.5 operations. Now, when we say operations, we mean add, subtract, multiply, divide. Those type of operations with rational numbers. Okay, that is our 21. So, quickly flip to the correct page in your notebook, and I'm going to just put 21 in the top corner of my page there because I know I'm going to trim it all out and it's going to fit nicely. All right, let's get started. We're going to work these problems together, and then I encourage you to practice in IXL. Right now, IXL, you might want to write that up there. IXL has the best practice problems for you. You get 10 free questions a day, and you can get help on that from your teacher. Just raise your hand and she'll help you with that. It's a really good practice, best thing you can do to prepare for the test, and it has questions just like what we're going to cover here. So you can see that I hand wrote these questions on lined paper to help keep you organized as you're working the problems. And I'm going to try to use these lines the best I can. We also should be using our notes from page 20. If you remember, we have these great notes about steps to follow when working these problems. We have hints, and never forget in the front of our notebook, we have the how to work fractions and decimals. We have our foldables on page 7 on fractions, when we're dividing, multiplying, adding, or subtracting fractions, and then below that, how to handle decimals. So we should be good to go. You also are going to need a calculator. You really should be working just with your blue calculator. I don't happen to have one at my desk, so I'm going to use the silver calculator, and I just will not use the plus minus. This is the only thing that this calculator has that your blue one doesn't, but never fear, I'm not going to use that. So let's get started. I have my paper, I have my calculator, and I have my pencil. I'm ready to go. Problem number 1, I'm going to be adding a decimal and a fraction. And like I said on page 20, the easiest thing to do is when we have fractions and decimals together is to change everything to decimal form. I'm always going to do that, and I will stick with that unless my fraction is a repeating or long decimal. So 1/2 I know is 0.5, but it's important that I maintain that it's a negative 0.5 plus negative 3.1. So I'm adding integers. Signs are the same. So the two armies are on the same side of the war, so they're just going to come and camp together. So that means I'm just going to add them together. Same signs, I add and keep the sign. So my answer will be negative, and all I have to do is add 3.1 plus 0.5, and I get 3.6. Isn't that simple? You have to just remember the rules when adding integers. Here, exponent to another exponent. Well, PEMDAS, remember our lovely PEMDAS, please excuse my dear Aunt Sally, tells us that we do exponents before anything else. So I know that 7 squared is 7 times 7, or 49, plus 6 squared, which is 6 times 6, or 36. So that's an easy one. 49 plus 36 is 85. 7/10 plus negative 5.5. Okay, I'm going to put that in parentheses to separate my negative and my add. So a fraction and a decimal, they need to be in the same form. I know if I box top 7 divided by 10, I can get a decimal of 0.7. That decimal doesn't repeat or anything, so it's just easy for me to continue with just adding them in decimal form. Now, I have negative army on this side and a positive army on this side. So they're not going to just camp. They would fight and take each other out. So instead of adding, even though it says add, I know I need to subtract. So if I have 0.7 minus 5.5, my answer is 4.8. Now I'm going to ignore this negative and I'm going to go back and check who had the bigger army. Yes, the negatives did have the bigger army, so the answer would be negative 4.8, because you take the sign of the bigger number. All right, I'm going to move a little faster now. Oh, I said that, but this is a harder one. I'm going to go back to my PEMDAS and I'm going to look. I have division, which is my D. I have subtraction, which is my S, and I have exponent, which is my E. So what do I do first? That's right, I need to take care of this exponent first. 10 squared is 100. And I'm going to carefully write down the rest of the problem. Now, I have a division step here. Division comes before subtraction, so I need to take care of this first. Normally, I would put this in decimal form, and then I would just use my calculator. But when I box top 2/3, I'm going to get a repeating decimal. That is not helpful. So I could estimate it, but I can handle putting 10 as a fraction. So I would write 10 over 1 divided by 2/3. Now, going back, like I said, to page 7, with my fractions, when I'm dividing, it tells me I'm going to keep the first fraction, that would be my 10 over 1, change division to multiplication, and flip the second fraction. Then multiply the top across, multiply the bottom across, and simplified. So 3/8 stays 3/8. 9/12, I would change it to multiply, and then I would flip the second fraction, then multiply 3 times 12 to get 36, and 8 times 9, 72, and reduce. I've got it. So, here we go. I'm going to say 10 over 1 stays 10 over 1. Flip my division to multiplication, and what do I do with the second fraction? That's right. I'm going to flip it over and multiply it out. 10 times 3 is 30. 1 times 2 is 2. And then if I box top my answer, 30 divided by 2, I get 15. So this equals 15, because 30 divided by 2 is 15. So all of this was to get me to 15 minus 100. Now, I'm going to have a negative number, because if I only have 15 and you take away 100, I'm going in the hole. So, 15 minus 100, my answer is negative 85. You can check your work by saying add a line, or keep, flip, change. Signs are different. So you subtract and get 85 and keep the sign of the bigger number. I know I wrote really small there. If you need to, at this point, you can pause the video and make sure that you get it down correctly. So, all right. If I could get that to zoom a little better, how about I just continue like this? Here I have a fraction and a decimal, so I'm going to change them both to decimal form. So I know I keep my whole number, -1. 1/5 I'm going to change to a decimal. So what is 1 divided by 5? You probably have that memorized. That's right, it's 0.2 plus 1.4. Now look, this side of the army is negative, this side is positive. So what are we going to do? Signs are different. Exactly. We're going to have to subtract. So 1.4 minus 1.2 is 0.2. And that looks like a 3. Please know that that's a 2. Which side wins the battle? Who had the more? The biggest army was the positive, so my answer is positive. So just 0.2. All right, here we go. What do we do first? Add, subtract, or the exponent? That's correct. The exponent. And 10 squared is 100. Write the rest of the problem. Excellent. Now, add and subtract, even though the A comes before the S, and please excuse my dear Aunt Sally, we do it at the same time left to right. And when you go back to our problem, it just so happens the addition is first. But I'm just working the problem left to right. So 7.4 plus 1 is 8.4. And I can put that straight into my calculator. 8.4 minus 100, the answer is negative 91.6. You could check yourself by saying, yeah, when you can't really subtract more than what you have, unless you add a line, And then here you can see, ooh, I only had an army of 8.4, and this person had an army of 100, so the negatives win after taking each other out. Okay, next problem is easy. You're going to work my exponent first. 2 squared is 4, and 1 plus 4 is 5. Don't you like those easy ones? Here again, I must have really liked 10 squared. Now, don't be tempted to do the subtraction and work left to right, because I have a subtraction, which is my S, and a division, which is my D. Which one comes first? That's right, the division comes first. So I need to divide. 100 divided by 5 is 20. Okay, I'm so taking away more than what I have, so I better add a line, add a line. Signs are different, so I'm going to subtract and keep the sign of the bigger number. Okay, the last 4 problems are in front of us. They're not easy, but I'm going to suggest that you really exercise that pause button. I want you to pause the video and do as much as you can until you get stuck. And then you can watch me catch up and then pause it again and see if you can move forward and kind of work the video to see how much you can do on your own. If you think you can get all the way through, write lightly with your pencil, so if you do make a mistake you can erase it, work the whole problem, and then go back. Here we go. So if you're going to try to do this on your own, pause now. All right, I have a subtraction and an exponent, so I need to work my exponent first. This is the same as 2 times 2 times 2. Base number 3 times, so I know it's 8. Writing the rest of my problem, I now have a fraction minus a whole number. I need them in the same form, so I'm going to box top my 5/8. 5 divided by 8 is 0.625 minus 8. Now, I know that I have just a little bit of change, and I'm going to take away like $8 whole. So my answer for sure will be negative. I'm going to add a line to show that I'm having a positive plus a negative. So I need to actually subtract that. I'm just going to put into the calculator how it was, 0.625 minus 8, and get negative 7.375. You would say that as negative 7 and 375 thousandths. If you were to actually take your calculator and subtract 8 minus 0.625, you'd get the same thing, and then you would see that 8 is the negative. Okay, let's try this one. I have the fraction here. I'm going to box top, and I hope that you guys know 9/10 is 0.9. So that there's always a decimal between a whole number and a fraction. That's where the decimal goes, and that's 0.9. So this is negative 5 and 9/10. You would say it the same as a decimal as a fraction, plus 4.5. Signs are different, so I'm going to subtract and keep the sign of the bigger number. So 5.9 minus 4.5 is 1.4. But who won the war? The negatives or the positives? That's right. The negatives have the bigger army. There are more negatives. Okay. 2/5 minus 3 squared minus 2. Exponents need to be done first. And then write the rest of the problem. I'm also going to change my fractions into decimal form. You can box top to get that. Since my first number is positive, I know I can put it straight through the calculator. 0.4 minus 9 minus 2 equals negative 10.6. If yes, you could have gone add a line, add a line, add a line, add a line, and you could have done it that way as well. And the last problem is not hard. 2 minus 3 plus, and yes, I need to do my exponents first, but 1 times 1 is just 1. And then even though subtraction looks like it comes after addition, it doesn't. It's left to right at the same time. So if you put into your calculator 2 minus 3, hope you'll see that you get a negative 1. You could add a line, and see signs are different, so you subtract to keep the sign the bigger number. And if you have minus 1 plus 1, you have a 0. That's right, it's a 0 pair. Awesome. So those were our computation problems. Let's look at our real world problems. We're almost done, but this is the challenging part. So you'll have to do something like this on the test. So I hope you pay close attention and work this with me. I go shopping and I wanted to buy some pumpkins, but right next to the pumpkins they had some mystery product. It's kind of expensive too, $3.24 a pound. I wonder if it's something that goes with pumpkins or if it's truly a treasure like chocolate. But I'm going to have some of it. I don't want to buy a lot of it. So I'm going to go ahead and purchase 4 pumpkins. And I'm going to purchase 1/3 of a pound of the mystery product. And then what is my subtotal? Now subtotal was written on purpose because I don't want us to have to worry today about tax and things like that. Discounts, coupons, just flat out what would it cost before any of that. So we're going to start by adding up our 4 pumpkins. Now you could write 450 plus 450 plus 450 plus 450. But since I'm in 7th grade, I'm just going to say 4 times $4.50. Okay, and then I am going to add a little bit of my mystery product. I'm going to buy 1/3 of a pound, so 1/3 times the cost of the mystery product, which is $3.24. So this problem can get pretty hard to work. So oh, and notice I went over my spot here. I'll have to be careful when I trim that out. So I'm going to have, as a matter of fact, I'm going to rewrite that down here because I don't want you to run out of space. You're going to need to be able to show every step of this problem. So first of all, notice that I have a multiplication step here and a multiplication step here. I need to do these separately before I add, because PEMDAS tells us that multiplication comes before addition. The first step is very simple. I'm just going to put 4 times 450, and I'm going to get $18. So the pumpkin part of my purchase is just $18. And then I need to add to that a more complicated step. Because when I put 1/3 into the calculator and I try to box top that number, I'm going to get a repeating decimal. So that tells me I need to instead keep it as a fraction. And I'm going to multiply 1/3 times 3.24 over 1. Okay, now there's another way to do this, but I believe that this is going to be the easiest way. So I'm going to bring down my work, and I'm going to work this step out by multiplying straight across and getting 3.24 divided by 3. This you can actually do in the calculator. Remember, this fraction line means divide. So this is an addition step, this is a division step. So I need to divide first. So 3.24 divided by 3 gives me, look at that, perfect, $1.08 plus my $18. So I end up with $18 plus $1.08. I bet you could do that in your head, because 18 plus 1 is 19, and then you still have the 8 cents. All right, one last problem for this video. I'm going to make cupcakes, and my total amount of flour that I have at home is 9.5 cups. But each cupcake takes 1/4 of a cup. So I'm going to be dipping into that bin of flour over and over again, 1/4 at a time. So what that looks like is, if I have 9.5 cups of flour and each cupcake takes 1/4 of a cup, I need to divide to find how many cupcakes I can bake for my students. So I'm going to start with 9.5 cups, and then I'm going to divide that by 1/4 of a cup. Now you know what I'm going to do, right? I'm going to change those to decimals. So this is 9.5. I hope you know that 1/4 is 1/4, so it's 0.25. Then all I need is a calculator and say 9.5 divided by 0.25. And I would get an exact amount of 38 cupcakes. My goodness, this will be a long video, but you've learned a lot and you've done a lot. So trim this out, put it into page 21.